For reference, I put up a page that has some contact information on who at Verantis to get a hold of. I'm the first one up there, Jay Janning, for sales request for quote, anything related to the fish program that we're going to go over today, and troubleshooting. You can go ahead and get a hold of me. That's my email and my direct dial number. Second on the list, we have two other gentlemen that are also in the sales department with me, Ralph Edgley and Michael Cheeser. And the last name on the list there is Mike Gradle. He's our engineering manager. Great go-to guy if you have technical questions. So I'll leave that up for just a minute if you want to go ahead and get any of that information. Certainly, if all you get off that, if you just get my name and phone number and want to get a hold of me, I can certainly direct your question to the appropriate party. All right. So we have about 40 people in here. There might be a few latecomers, but we're going to go ahead and start. All right. First of all, I'm going to just give you a little brief summary of what we're going to cover here. We're talking about our FISH program, which stands for Fan Integrated Sales Helper. First, I'm going to go over basically how it works, the short mechanics of it, and this part of it might be kind of quick. I use this all day long, and I'm very familiar with it. What I'm basically going to do first is just go through and show you how the program works, how to navigate from the beginning of putting in information to the end of it, either requesting a quote or downloading some information on the fan that you've selected. After I go through it quickly, I'll back up and talk more about the fan selection itself, tips and guidelines. I'll do a couple of examples that I've picked, and then at the end of the session, we'll entertain any questions that we have. Hopefully, the first three portions of this will take about 35, 40 minutes, and then we'll try to save the remainder of the time for anything specific and questions. And I have a poll that I'd like to start with and just kind of get a gauge of where everybody's at. So the question here I'm posing is, how comfortable are you with the fan selection process? And I'm going to give everyone maybe 30 seconds, 45 seconds or so to go ahead and answer that question, and then we'll see how we are. All right, at about 90% of the people have voted, and I'll give you another minute or another few seconds here to get you voting if you haven't. All right, so we're gonna see how everybody is, where everyone's at here. We have the majority of the people, about 50% of the people, are pretty comfortable with fan selection. And I have 23% of you need to send your application in to us. And for the other 17% listed here, hopefully we'll be able to shed some light on fan selection. So let's get started with fish.verantis.com, and I seem to be still showing poll results. Let me hide this. Sorry about that. All right, so here's our main login for the FISH program, fish.verantis.com. Hopefully everyone that's signed up in here has already registered for this and at least hoped a little bit at the program. So I'm going to go ahead and log in here. And your first screen that pops up basically gives you the option to size a fan or to log out. Let me see if I can get a little pointer here. Let's see. All right, we'll try a spotlight today, see how this works out. So you have the option here to size a fan or to log out. If you have any problems with changing your password, you can always get a hold of me, and I can get a hold of the IT department to troubleshoot any technical problems. As far as the saved fans, I have a few in here. It's a function that happens at the end of it. So again, I'm going to kind of briefly go through this and then talk about the saving fans. So we're going to start out real basically with sizing a fan. And let me just double check that it's coming up. What you need in order to use this program is volume and your pressure. The program was written to just be very simple. Those are the only two inputs you absolutely mandatory have to put in. If you know what the inlet pressure is and the outlet pressure, you can get a slightly more accurate calculation. If you know the density of your airstream, that will also affect the calculation. The temperature right now, as noted right here, you must correct your density for the temperature other than 68 degrees. So changing this temperature will not change anything. Your elevation will change your calculation. Mostly it'll just change your density. But bare minimum, you need a volume and a pressure. And we do have the ability to use different units. You can also choose metric if so desired. So I'm just going to leave the default settings in for right now, 1000 CFM at 1 inch of pressure. And I'm going to click here on next. And this will take you to our two basic different fan types. We have a centrifugal and axial. When you click on centrifugal, it'll show you our basic fan models. The Club, CH, CHP, and the CMH series. I will go into a little bit more discussion as to each of the different fan models in a moment. We also have the two axial fans, a regular FL axial fan and an FLR. The R refers to like a rooftop unit that sits upright. So you select a fan model. It'll give you a brief description about what this impeller is basically designed to do. The little asterisk here indicates that it's AMCA certified. And you have the ability to compare it to a second fan. So you can actually, in this portion, select two different fan models. And I'm going to click Next here. Now it'll show you of the fans that are available given the design conditions that you entered in, what is available. Again, I'll talk a little bit later about actual fan selection and what we look for in guidelines. For right now, I'm just going to pick two of these fans and click Next. And it'll put the fan curves of these two fans side by side so you can further drill down and look at your options. When you pick the fan that you like, you're going to check the box here underneath the graph and click Next. And this takes you to the final stage, basically, of your fan selection. I know it went rather quick. You have up top, let me get my little spotlight here. You have one button that's going to give you all documentation. And this is something new that we've added in from our customers' feedback. Clicking on this button will take you to the ability to download the sound and fan data, the drawing, and the fan curve all at the same time in one PDF. If you don't need all three of those, you have the ability here to download just the items that you need. Here we have a request for quote button, which will basically save your fan that you've selected and then prompt the system to tell Verantis that there's a request for quote, and the Save Fan button. If I go ahead and click this Save Fan button, just to kind of lock this one in, it will push the fan to the front. And excuse me, I'm going to do this rather quickly here. I'm just going to go all the way back to the beginning and make sure everyone can see that. You can see right here, these are the saved fans that when you click that Save Fan button. And then you can always go back and reference, and if you look on the View Data sheet, you can always go back and you can get that information that you've already saved. So that is the short, quick basics of how the program is going to work. Now I'm going to go back through it again a little bit slower, and I'm going to kind of discuss, maybe I'll just go ahead and put in one of the examples that I have from a customer recently, and we can kind of go through and discuss this one and fan selection. So I have a customer that contacted me and said that they need 12,100 CFM with 6 inches of pressure. And the only other consideration that I received from them was that they had a 24-inch ductwork that they'd like to connect this into. So only given that information, I'm going to walk through this example and just talk briefly about what it is that will center me in toward a specific fan. So first of all, I'm going to stick toward the centrifugal fans. And typically, because our Club Series fans are most efficient, I'm going to start there. But let me just kind of pull up a little drawing here, and I'm going to pause from the normal program, and let me make sure that everyone can see. Okay. Yep. So the basic the three basic wheels that we have here are listed on the half PDF that I've kind of cropped off the picture here. The Club Series fan, the B in Club, represents our backward inclined impeller. And I just went over that. Sorry about that. It's our most efficient of all of our fans. The backward inclined impeller is made for, as it says, light duty, clean air, light particulate, light dusty conditions. The reason this is that if there's a lot of particulate in your airstream, it will build up on the backside of the impeller. It will cause the impeller to become imbalanced. And on the worst case scenario, if you get a lot of buildup, sometimes chunks of it can dislodge itself and really cause the impeller to be imbalanced, and then have further vibration issues. That's our real basic. Let me get my spotlight back here. That's our basic backward inclined impeller for a visual there. The next fan down, the CH. Let me click on that one and pull this back up. The CH fan is a forward curved impeller. Tends to run a little bit slower. You can see here the design and shape of it. It's made to do more of a heavy-duty, dirty air, heavy particulate. This is much better if you have a lot of particulate because it is self-cleaning impeller. You're a lot less likely to get buildup on the impeller. Tends to be a little less efficient. Although if you noticed, and let me toggle back here, the club fan goes up to about 18 inches of pressure with a high volume. The CH fan, we can get a much higher pressure with this forward curve design. And lastly, let me click on the up. Now we'll get to that in a moment here. The P. The P is for paddle wheel. And given the design conditions, maybe this is a good thing to explain. Given my design conditions that I put in, 12,000 CFM at 6 inches, this fan, the CHP fan, is not a fan line that will perform given those design conditions. So you're going to get this really generic line that says, please contact Verantis. And when you contact me and ask me why you can't pick a CHP fan, it's basically because that fan will not meet the performance that you've entered in. So I'm going to jump here. If you see backward inclined, forward inclined paddle wheel, the next 3 fans in line follow the same pattern. The CMH series fans, we have a backward inclined, R is the forward inclined, and the P for paddle wheel. So I'm going to pull this up just so you can see the basic description of it. You'd see a very similar description on the CHP if I were able to select it for these design conditions. But the paddle wheel is a straight radial impeller design, great for high pressures and low flows. This is extremely high self-cleaning, great if you've got a really heavy particulate. Typically, in placing a fan into a system, a lot of you will have the question of, do I go with a paddle wheel, a forward curved, or a backward? As a fan manufacturer, we tend to recommend using the backward inclined in extreme clean environments. How this translates to you as our customer would typically be after the scrubber. If you have a system design where you're looking at putting a push fan before the scrubber, we tend to like to recommend the paddle wheel and the forward inclined impeller design, simply because of the heavy particulate that the fan is going to see before it actually gets into the scrubber. This is information that we love to know in advance. So if you are coming to us with future requests, please share that information with us. So that's our basic rundown of the different fans and the impellers. So again, we have the backward inclined, forward inclined paddle wheel, backward inclined, forward, and paddle wheel. So usually when I first get a request in with a flow and pressure, I'll start here with the club fan, knowing that it's one of our more efficient fans, and I might select, randomly one of these other ones, and here I'll go ahead and pick these 2 right here and click next. Now the information that we have here, there's several different things that will lead us to sizing and picking the right fan. I can do what I've learned. I can follow guidelines from predecessors. What it kind of comes down to is what you as the customer are looking for. Some people want to focus solely in on static efficiency, which if you look at these 3 examples, maybe you'd pick a Club 3000, maybe you'd pick the Club 3650 based solely on efficiency. Again, if you knew that this was going to be a really dirty environment and wanted to avoid the backward inclined impeller and you wanted to look more at the forward curve design, you might choose the 30-inch over the 24-inch based solely upon the static efficiency. There's also, if you're considering sound, if it needs to be in a quiet environment, obviously a Club 3650 is the quietest of the 5 fans up here, along with the Club 3000. Sometimes I have one customer who says, Jay, please don't ever size me a fan that's rotating more than 2,000 revolutions per minute, in which case I would automatically throw this fan out because it's a little over 2,000, and I'd be driven more toward any of these other 4 fans. We also consider the outlet velocity. Sorry, I'm really marking the page up here. Let me clear this to make it a little simpler. The outlet velocity of the fan. The basic guidelines that we're going to give on the outlet velocity is for our Club Series fans, nothing over 3,500 feet per minute. In which case all three of these fans are safe. This one comes a little bit close to it, but it's still okay. On all of our other fans, the guideline is about 4,500. And again, both of these are well within the realm. But you as the customer really need to look at the outlet velocity in pushing the air out of the fan. Once it leaves the outlet of our fan, what is it pushing into? Is it pushing into your scrubber? And do you want air traveling into your scrubber at 40,000 feet per minute? If you're okay with that, we're okay with it. Now, all that being said, looking at the technical information, really what's going to drive the next question is how it looks on the fan curve. And while I will not proclaim to be a fan curve master, I'm going to go ahead and just select two fans here. We'll look at the fan curves. Oh, and my drawings carried over, so let me clear these. This is a real typical curve for our backward inclined impellers, the club fans. You have a nice raise here, but then it kind of starts, going off to a peak somewhere around here. Now, the general guidelines that we're going to give on fan selection and fan curves is we avoid, and it's appropriate that this is red, we really try to avoid this top section of the curve, anywhere that gets close to the peak, and anything down on this section. Maybe you could say the top third and bottom third, that might not be an even proportion, but we really kind of, the fan drops off here into an area that you don't want to run the fan. It can get real noisy. It can get heavy vibration. And up here you have the chance of the fan stalling out if it kind of waffles in between that point and the point somewhere over here on the other side of the curve. So we always try to recommend a fan that has an operating point. Here, I'll make that little operating point right there bigger. That's somewhere in this kind of middle section of the fan curve. This point still is okay. It's still away from the peak, which might be right around here somewhere. But again, looking between these two fans, I might lean a little more toward the Club 3000 than the 3650, just because it's a little more centrally located. Now let me pull up in comparison this with maybe this fan right here, the CMHR30, and compare these two. Now the CMH30, that's maybe a bad one. Let's try this. We'll do the Club 3000 and the CMHR24 just to show these two. You can see that the shape of the curve is much different. You have a much steeper slope on this line. Your peak is probably somewhere right up in here, and this is, clearly way away. If I was to pick these two fans solely based on their position on the curve and how comfortable I was with their operating point, I might lean a little more toward the CMHR24. Again, there's a lot of factors that go into fan selection, and when it comes down to it, the more information you as the customer can give us, the better we're going to be at picking a fan that's going to meet your needs. Now, again, there was 3 pieces of information that I was given from the customer. First, 12,000 CFM. Second was 6 inches of pressure. And third was that they were connecting into a 24-inch duct. And knowing that they're connecting into a 24-inch duct, I might, right off the bat, go ahead and select the CMHR24. It has a 24-inch round inlet, and while it has a rectangular outlet, if they're connecting to a round inlet, we can do an integral or separate transition. And this might be one of the better selections for them. And they'll have to decide based on that selection if they're okay with the efficiency, if they'd like something a little more efficient. Certainly we can talk with them about their system design. If they have the ability to do a long transition, we can do a more efficient fan like the Club 3650, and then work on transitioning that through their system. There's a further discussion that goes into the right fan and the right system, but we're gonna stick primarily just with fan selection today. So if this was the fan that I was going to select, I'd continue onto this next page. I'd select the fan and go to this page. I'd be able to, and here I'll show you on this side of it. When you click this all documentation button, what this is going to do, it's going to generate a report with our basic fan data. It'll show your flow and your pressure that you entered in, your basic conditions. It'll give you your brake horsepower under operating conditions, the RPM that the fan is going to be rotating, static efficiency, sound power levels, estimated sound pressure. It'll obviously show you who sized the fan. It'll put the fan curve in here. And then it'll also produce a general arrangement drawing for the CMH series fans. And this is based on the size that we picked. It's automatically defaulting to an arrangement 9. And here is the CMHR 24 fan with all the information here. This drawing will populate. It's for reference only. Depending on the motor size that's being put in and a few other factors. These drawings here, also, if you look at the small print here on number 4, dimensions not to be used for construction, certified prints are available. If you need very specific dimensions and drawings, please contact Verantis, either myself or Mike Gradle, to get more descriptive drawings. All right, let's close this down. Oh, I'm sorry. One more thing too here is that basically this printout here is what you can save. Oh, sorry. There was one more drawing attached on there, which is basically the flanges. Here's your circular round for your inlet, your rectangular for your outlet, and then some general information on the transitions that we have as well. All right, and I'm going to close this. And again, these are all available if you just need the sound data or the drawing or the fan curve individually. They're there. And while we're at this point too, we'll talk about the request for quote button. What this is basically going to do is, I believe the text box here is limited to 255 characters. So that's not going to give you a whole lot of space in order to tell me everything you need to tell me about the fan. Also, if you have a project that requires specification review, there's nowhere really to tag it. What this button is going to do right now is it's going to raise a flag here at Verantis that someone needs a request for a quote. That'll come across to us. We'll go ahead. We'll look at it. I'll have your contact information that's filled out. We will shoot you an email and saying, hi, this is Jay. Thanks for taking an interest in our product. Please let me know how I can help you. And the only information that's going to carry across is the flow and pressure in the fan that you were looking at. If you have special features on the fan, if you have a corrosive environment, high temperature application, a huge list of other information that we're going to need to know, we're going to come back to you for more information. Let me switch back here. All right, so that was one example that we went through. I'm going to go ahead and I'm going to quickly go back to the beginning. And I'm going to show a second example here. And this one is just going to show some of the high capacity that we have. Again, I'm gonna start here with the centrifugal fans, the club, and I'm gonna click on the CH, and it says that please contact Verantis. So I know the CH fan and I know the CHP fan aren't going to be able to do this. The CMHB won't do this. And I did this already, so I know that the paddle wheel will not do this. The only other option we have is the CMHP. So between these two, you have two options for your fan that's going to be able to meet the design conditions of 100,000 CFM at 10 inches. And if I select these two, actually before I even go any further than that, I'll just highlight that both of these are pretty high outlet velocity. This one more so. Depending on your system and what you're trying to do, how big your ductwork is, this might not even be an option, just to mention it, but you know, the fan selection program will still let you pick a fan. And we can see both of these points on either of the curve work well. You know, certainly we're avoiding this lower section and this upper section. And again, on this one, this section here and this upper part of the curve. So both of these fans could be options for a really high flow and pressure. And again, it would go to the next same point where, you know, you pick the two, one of the two, and move to the next point at generating your information. So that just kind of highlights our ability to do a really high flow with high pressure. And on the reverse side of that, let's do 500 CFM at 8 inches. And again, notice I'm only putting in flow and pressure onto these. I am not including density. I am just letting the standard density run. Again, if you know that the density is anything beyond a standard, that information is pretty key in putting that in. But for our examples today, we're sticking with the defaults. So this one is an example of a really low flow, 500 CFM. And again, I can go ahead and, you know, maybe pick the club fan, and I'll pick the two backward inclined impellers to start with here. So I'll pick the club with the backward inclined and the CMH series fan with the backward inclined. And here it's only showing, before you might have noticed there were 3 fans, now there's only 2 club fans that'll fit into this, and there's 2 fans here. And you heard me say before that our club tends to be our most efficient fan, and that will also depend greatly upon the design conditions that are given. In this case, 500 CFM at 8 inches, the CMHB fan is a much better choice solely based on the inlet or the static efficiency. If I were to, just for example, show these 2 fans and compare the curves, here's a great example of where our operating condition is so far up near the peak of this fan, we would not recommend this fan to be used in this application. This is a much better point. It's got plenty of leeway here away from the top of the curve, and just kind of shows, based on the static efficiency, but also its position on the curve, that the CMHB is a much better option to choose for this application. Now, I'm not going to stop there because there might be a better fan to pick. So I'm gonna start here with the CMHB, and I'm going to compare it maybe to the CMHR fan to see how that does. And obviously we hit that where this fan is not going to be able to work. We'll maybe try the paddle wheel. We can select the paddle wheel. So putting the backward inclined against the paddle wheel, again, if this is a clean application and you're looking at static efficiency, the 6 right here would be the best based on the static efficiency. If this was a a really dirty, heavy particular environment, even though the static efficiency is lower, the CMHP, the paddle wheel fan, might be a much better selection. And if we go ahead and look at maybe this fan and its counterpart, the CMHP6, we can see the comparison here. This is still a good point on the CMHP6. We wouldn't necessarily discount that. You know, and there's further discussions we can have on what we can do in customizing this fan and making this a good selection. Let me go back here. And just for the sake of argument, I'm going to look also at the CH and the CHP. We can do either one of those. There's only one option here. It has a lower static efficiency, so you know I might still gravitate more toward the backward incline. And let's check this one as well just to see. 37%. So, you know, again, I'm flipping in between these rather quickly only because I use this program day in and day out. But once you kind of pick the fan that you like, you know, you can put that in the fan model number 1 up top, and then kind of bounce between the other ones and compare it to see how it compares. So there's a low flow application where we're looking just at 500 CFM at 8 inches. And I have another example that I'm going to put in 5,000 CFM at a ½ inch of pressure. And this one is kind of a loaded example here because I could click through these examples and we could you know try to find a fan that's going to be the best fit for this. But really, when I'm giving something as low as a ½ inch of pressure, I know most of our regular centrifugal fans are not going to do really low pressure like that. So given 5,000 CFM at a ½ inch of pressure, I might start with going toward the axial fans and seeing what an axial fan has to offer. And you can instantly see right off the bat that this static efficiency jumped quite a bit. The very low flow applications, our axial fans are a much better fit. Now this curve is very different from the other curves that we've seen, and I'm just going to talk about these briefly. You know, we see that it kind of plateaus in this area here. It's nice that it does that because it kind of shows the area where we're going to kind of select our point in. We're going to avoid anything up here in the top left section, and we're certainly going to avoid anything that drops off here. Both of these, there's a point right here and a point right here. Both of these would be a good pick for this application, 5,000 at a ½ inch. Maybe the final selection of which one of these two fans would be a better pick would be based upon the ductwork that it's going into. If it's, you know, a 24-inch ductwork, 30-inch ductwork, maybe it's 28 or 32 inches. We can talk about transitions. If it's 22 or 26 inches, you know, basically more information from you as the customer helps us to gravitate more toward, you know, which one of these two would be a better selection. So those are basically some of the examples and how the program works. You know, what we do as far as fan selection. What I'm going to do is I'm going to open up our chat box here in questions. I apologize if anyone's already put any questions in. We kind of really haven't been looking at that, but what I'm going to do now is if you want to put some questions in there, I'm going to go back up to the top of the question list, and let me backpedal just a brief moment and maybe introduce a few of the people that I have in here with me. I have Ralph Edgley, who's my comrade in arms, our senior sales engineer. I have Mike Gradle, the head of our engineering department, our engineering manager. Mary Rusnick, who organized this, as our marketing manager. Jeff Worth is our general manager. And sitting in the back of the room quietly is Ryan Fisher, who is in behalf of our IT department. He's here to make sure that if anything crashes, he can fix it quickly. So I'm going to go back up to the top of the questions and address these briefly. The first question came across: can we download CAD drawings of the final fan selection? The only drawings that are available right now through the fan selection are the general arrangement drawings. CAD drawings, we do have a pretty extensive library of CAD drawings of previous jobs that we've done. Certainly if you're looking for a very specific drawing on your application, we might have the right orientation and rotation available. Please contact me if you have something specific that you're looking for. As far as drawings of the fan that you're going to need, usually we have the engineers go ahead and do those. The best way to get drawings is once we get the order placed, we can have an engineer do those drawings up for you. If you show the entire curve to shut off, we could be better determine where the last usable point would be before the hunt portion of the curve.
That area to the left.
Talking about the area to the left, yeah. Mike Gradle says.
Yeah, what we show right now is 5% to the right of the peak. So we don't show what's at left because a lot of customers will try and select in that area and it's just a bad area, so we don't show it.
Okay, hopefully that answered that one. How can we use the program to direct drive fans? Can we specify the speed? No, the way this program works is you enter in a flow and a pressure, and through the fan laws it will calculate the speed. Direct drive, arrangement 4 or arrangement 8, really the fans will automatically default to an arrangement 9 or an arrangement 10 belt drive, just as a default for the size of our fans. And that primarily is, the direct drive isn't going to affect the performance of the fan. So what this program is used for is getting your basic information. As far as making it direct drive, that opens up a further discussion if you're going to be using a VFD to control the speed, or if we're talking about just motor straight to impeller with no speed control. That's a whole different discussion that, if you want to contact me, we can maybe try to provide more information. Does that kind of cover? Yeah, Mike Gradle shaking his head at me that I probably answered that as far as why is density on the fan selection page not the value as inputted?
Being corrected for the negative inlet pressure.
Yeah, if you didn't hear that, Mike Gradle says it's being corrected for the negative inlet pressure. Remember at the beginning, I'm putting all of our pressure here at the inlet. If I were to, if you knew you had 10 inches of pressure and I were to split that between the inlet and the outlet as appropriate, you would get a more correct density value. Also, one thing that I might have skipped over, and let me go ahead and just briefly get back to this page. I'm just going to pick a quick fan here to highlight it. Hold on, sorry here. I'm gonna pull this page up because maybe this will help with that discussion. If you look at this, it's going to show your operating conditions on one side and your standard conditions at the other. This standard condition side is always going to show your density at standard elevation, standard density. It'll just default there. if I were to, maybe I should do this just for show. And there's my mouse. Let me go back, and I'm going to go ahead and just put in something else for density, maybe just to highlight this. Again, I'm gonna go ahead and pick the same fan as I did before. And we'll look at that same, and we'll show the difference here. So now you're going to see over here on your operating side, it has the density. It didn't correct anything because I didn't put any elevation in. The program assumes that you've corrected your own density for the temperature. When you look back over on the left-hand side, you're going to see it's still going to show your density, your standard density, zero elevation, your standard temperature. And the consideration point of this is that if your density is being driven by a hot process, if you're running at 140 degrees and that's affecting your density, when you start your fan up, if you're doing what we might consider a cold start, the brake horsepower required to start the fan up is going to be at standard conditions. It's not until you get up to your higher temperature with your reduced or altered density that you're really going to have a difference in the brake horsepower requirements. So in this situation, if you've got a different density, I'm not only going to look here at this brake horsepower, but I'm going to look at the startup required brake horsepower. And depending on the application, granted, this looks like it's very slight, and you know, I'm going to just throw this out there briefly. Say a 2 horsepower motor might do it. If we're talking about a different set of design conditions, you might be able to run your process at, say, 50 horsepower, but you might need a 75 horsepower motor in order to get things. And that's a really generic, brief discussion that we'd have to look more at, you know, your specific design condition in order to better answer that question. But hopefully that kind of gives you a little bit better idea on that for the density as far as the input and standard. So next question, if I pick a fan too close to the peak of performance, do you support it? If not, take the selectable away from me so I don't select a fan I shouldn't have. Limit the performance curve to what Verantis would support. We certainly could do that. Ryan, our IT guy, is a genius, and there's nothing he can't do over time. However, if there's something close to the peak, because we are very customized in what we can do, just because a fan point operates close to the peak doesn't always throw it away. We as a FRP manufacturer have the ability to custom make fans, and that's not necessarily the end of the discussion. So we're not going to automatically discount something just because it initially doesn't look good on the fan curve. But certainly we're gonna go to engineering for a little more detail on that. So when dealing with fans of the same model, is the brake horsepower and efficiency remotely related?
I'm not sure about that one. I'm not sure what the question is. Related to what?
All right, so is the brake horsepower and efficiency remotely related to what? So Joseph, if you could type in a clarification, I'll keep an eye out at the bottom of the list and see if we can clarify that a little more for you. Caleb asks, is there any way to adjust the Q factor for sound levels, or is it always 1?
We don't have that. We don't have a way to play with sound. The only you can, and I don't even know if they have it, but I think you can adjust the distance for 3 to 5 feet. But that's the only thing you have. That's the only parameter you can play with.
Okay, so if you're looking for different sound information, the 3 to 5 feet is your only option on adjustments. How do you deal with gas versus air in the selection? Density, basically, would be the answer to that. Can you use the software to get a particular fan curve at a particular RPM that you designate? I think I might have touched on that. This software right now is used for inputting flow and pressure, and then it uses the basic fan laws to go ahead and calculate the RPM. This program does not work backward in putting in RPM. Joseph, you had another question here. I don't know if this is related to the first one, but of the fans I've dealt with from Verantis, they have been belt drive. Does Verantis offer direct drive fans? Yes, we do. We have arrangement 4, which is a motor directly connected to the impeller through a very small shaft. We also have arrangement 8 available, which has a standard shaft with bearings, much longer design with a coupling in between the shaft and the motor. Both of those we can offer either with or without a VFD, depending on the application. But again, that has a lot more discussion in it. But yes, we do have direct drive fans.
Hey Jay, if I could expand on the previous question about RPM, you can't select it directly, but if you know your flow or you know your pressure and you vary the other, you can work your way up and down in steps to get the speed that you want to see, either what pressure it will do or what flow it will do, depending on which one's fixed. So you can do it, it's just you have to kind of home in on it.
Okay, thank you. In the operating conditions section, data entry, if we need to change elevation or temp, does the program automatically correct the density? Show as an example. Okay, so in the example that I still have on the page, I didn't change the temperature, but I did change the density. If I were to change the elevation, maybe I can show this briefly, just as an example, so you can see how it would work. If I were to go ahead and put back in our standard density, but I'm going to change the elevation, and let's say we're sitting close to Denver, for example. It's severely inflated, but it'll show it pretty clearly, putting in 5,000 feet. Again, if you pause briefly here and look at the, I'm sorry, I lost my train of thought here. There it is, density down at the bottom. It's a 0.06. That's just kind of an intermediate calculation. You really need to take it to the final selection here and open up the sound data sheet. And now we're gonna look at this, and you're gonna see your operating conditions. Again, I entered in 0.075, and it's auto-corrected the density at 5,000 feet. And again, if you look back over on the left-hand side, it's still going to show your temperature, standard density, and 0 elevation. So you can see again the example of the difference in the brake horsepower requirements for startup. Now, again, this is a further discussion that has more detailed answer to it. If you're looking at a difference in brake horsepower solely based on elevation, certainly this elevation is going to hold true on the left-hand side as well. So, but again, I'm trying to be as general and non-confusing as possible on this. So, can we use the club fan on a dirty air side, for example, upstream of the scrubber? The quick, short answer to that question is yes, you could use it. Would we recommend it? Probably not, but that's also not the end of the discussion. We have seen some applications where they'll put a little water spray at the beginning of the inlet of maybe the ductwork right before the inlet of the fan. What that does is it intermediately sprays water into the fan to keep the backward inclined impellers cleaner. But certainly, again, with almost all of these questions, there's the further discussion. If the process that you're putting this fan into shuts down on a weekly basis, and the company has the ability to do some clean out and regular maintenance of the club fan, that's a huge consideration. with any of our fans, the maintenance schedule that we put out there is highly recommended to follow, because that's going to basically allow you keep your fan clean, and it'll run, a couple of decades. How does the allocation of pressure between the inlet and the outlet matter? It matters in the fan law calculation. Maybe, again, if I can highlight the difference here, and I see I've only maybe got a few minutes left. If you were to run through this example, try putting in 10 inches of pressure on your inlet, and then maybe try, go through it and look at the sound data. Go back and divide that 10 inches between the inlet, 2 inches and 8 inches, 5 and 5, 3 and 7, different combinations of that. And as you run through it, you'll see how it affects the curve and the density. It's a slight difference. If you know the inlet and outlet, it just gets you a more accurate calculation. Let's see. Trying out the program now, only getting the fan curve after selection. Again, explain how to get the data sheet. Mark, hopefully I went through that again. If not, give Ralph or myself a call, and we can walk you through how to get that. I answered my own question. Perfect. All right, sorry, all right, is the fan curve always at standard? Fan curve always at standard. Can I get?
I think that's a yes.
I believe so, yes. When you say clean and dirty air, what does that mean? For example, degasifier scrubber air is considered dirty. Dirty air and particulate. Joe, again, if you have more specific, you seem to have a lot of questions, please, drop me an email or give me a call, and we can, talk more about that. So, and Chris, you're asking about dirty air, and Mark, you threw in one last one there at the last minute. Velocity, pressure, and inlet. Mark, give Ralph or I a call. We'll talk about that. So, I hit 2:30. I actually can't believe I talked solid almost for an hour. I'd like to thank everybody for joining us. We had this recorded, so it will be available for download and future review. Again, I put out our contact information. If you have further follow-up, please get a hold of us. And I'd just like to say thank you for participating in our webinar. Have a good day.